This is HM-01, a health monitor that I designed and built from scratch. It brings together ECG, heart rate, SpO₂, pulse information, health monitoring, clocks, themes, settings, and more, all in one device. But one feature makes this project a little different. It tries to explore something that's much harder to see: stress. So in this video, I'll show you why I built HM-01 and how I brought this idea to life. But before I show you how I built this device, I want to explain why I started this project. Because for me, this is not just another electronics experiment. My aunt was diagnosed with cancer, and for several months I helped take care of her and accompanied her through hospital visits, checkups, chemotherapy, and radiation. During that time, I saw many physical health parameters being monitored: heart rate, pulse, ECG, and other tests. But it also made me think about something that is much harder to see: stress. My aunt continued her treatment, but a few months later, she passed away. I'm not saying that measuring stress could have changed what happened to her, but that experience left me with a question. We can monitor so many physical signals, but could stress related patterns also be something worth exploring? Later, I came across another situation involving a very young child facing extreme stress. That made me realize this question isn't limited to hospitals or adults. Stress can affect people in many parts of life, from home and school to work and healthcare. So I wanted to try something: bring together signals like ECG and pulse related information and explore an experimental stress indicator. It's not a medical diagnosis or a replacement for doctors. It's simply my attempt to explore something I feel deserves more attention in future health monitoring devices. That's how HM-01 began. To build the enclosure, I started by joining the PVC pieces together with superglue, gradually forming the main frame of the device. I designed the case to be compact while still leaving enough space for the display, controls, sensors, battery, and the internal electronics. Once the basic PVC enclosure was ready, I moved on to the outer design. I printed custom eco-vinyl skins based on the layout of the casing, then carefully cut each section to fit. Finally, I applied the vinyl skin to the PVC enclosure. This completely changed the appearance of the device, giving the handmade case a much cleaner and more finished look. With the enclosure ready, I started adding the main controls and internal hardware. I installed the mode switches, the main power switch, and the joystick used to control the device. For portable power, I am using an 18650 battery along with a charging and power conversion module. This allows the battery to be charged through USB Type-C while also providing the required power for the device. For ECG monitoring, I'm using an AD8232 ECG module. I also added an RTC module to provide the time and date for the different clock modes. For heart rate, SpO₂, BPM, and pulse related information, I'm using the MAX30102 sensor. I originally included a contactless temperature sensor as well, but during the final stages, it wasn't working reliably, so I decided to remove it from the final device. The main interface uses a 2.4-inch TFT display. For the controller, I chose an Arduino Duo. The display itself occupies many pins even when some of them aren't actively used, so I needed a board with enough additional pins for the sensors and other functions. The Arduino Duo also gave me more processing capability for handling the display and the different functions together. I also added a small buzzer for keytones and other device functions. At first, I also added 3 LED indicators to the front panel, but during the final design stage, I removed them because they were taking attention away from the main display. I wanted the display to remain the dominant visual focus of the device. And after connecting everything together, this is the final hardware taking shape. With the hardware finally assembled, it was time to bring the device to life through software. The code for HM-01 isn't a single Arduino file. The project is organized into multiple files, all connected through the main HUMANIX HM-01 INO file. I have included the complete code, circuit details, and documentation in the video description. Simply extract the project files, open the main HUMANIX HM-01 INO file, and the complete project will load into the Arduino IDE. I developed the software to bring the different sensors, controls, menus, and display functions together into one complete system. The goal was not just to make individual modules work, but to make the entire device feel like one integrated product. After completing the code and making the final connections, it was time to upload everything to the Arduino Duo. And finally, it was time for the first power on. And finally, the device turned on. After all the work on the enclosure, electronics, and software, this was the moment when everything finally came together. This is HM-01, my custom-built HUMANIX health monitor. The interface is designed around a simple main menu, controlled using the joystick and dedicated buttons on the front panel. From here, I can access the different functions and settings built into the device. I also added a settings section to customize and control different parts of the device. This allows the system to be adjusted directly from the HM-01 interface without needing to modify the hardware. For me, this was an important part of making the project feel more like a complete device rather than just a collection of sensors connected to a display. I also added multiple display themes. The goal was to give the same device a different visual personality without changing any hardware. With a few selections from the menu, the entire interface can switch between different visual styles. HM01 also includes multiple clock modes. I added both analog and digital clock designs, giving the device a few different ways to display the time. These clock modes are not the main purpose of HM01, but they make use of the display and RTC system, while also making the device more useful as an everyday desktop or portable monitor. Of course, the main purpose of HM01 is health monitoring. The device can display heart rate and pulse related information using the integrated sensor system. These values are shown directly on the display, allowing the user to observe the available measurements in real time. And when a stable signal is detected, the system can update the information directly on the screen. After testing the optical sensor, it was time to move on to one of the main features of this device, ECG monitoring. I connected the ECG patch cords to the device and prepared the electrodes. I then attached the electrodes to my body and made sure all the connections were secure. With everything in place, HM01 was ready to receive the electrical signals from my heart. And now, it was time for the real test. With everything in place, it was time for the first real test, the ECG. As the signal stabilized, the live ECG waveform began appearing on the display. The system was now receiving electrical signals directly from my body and displaying them in real time. Seeing a signal from my own body appear on a device that I designed and built was one of the most satisfying moments of this entire project. This is still a prototype and there is always more to improve. But seeing the complete system working from enclosure to electronics, software, and live testing was a major step forward. If you have any questions, ideas, or suggestions for improving this project, feel free to leave them in the comments. And if you want to explore the project yourself, I've included the code, circuit details, and documentation in the description. Thanks for watching. But the ECG test was only the first step. The next test was the feature that originally inspired this entire project, the experimental stress indicator. The system uses the available physiological signals and programmed references to generate an estimated stress level indication. I then tested the device under different conditions and observed how the readings responded. This feature is still experimental and I want to continue improving it in future versions. But for now, this project is only the beginning of that journey.